talk about this in the notes, so I wanted to go over it together. It says, what can be said about a set of data with a standard deviation of 0? So anytime you do the standard deviation, it's going to come up to be either 0 or positive. You can't ever get a negative standard deviation. But remember, it's measuring how spread out something is. If your standard deviation is 0, so if your standard deviation equals 0, what that means is your measure of how spread out it is going to be 0. So if we're measuring how spread out this thing is, you get back a 0, that means it's not spread out at all. So in this case, it's not spread out. So there's no spread out, there's no variation. So with that one, it's going to be, everything's going to be exactly the same. So you've got your 3 options here. C is not going to be the answer for every positive value. There's a corresponding negative value. That's not going to be the case because if that's the case, there is some spread to it, so that's not going to be it. Actually, if your mean is 0, then C is going to be the correct answer, but they're not asking about the mean. So it's not going to be C, because if it's standard deviation, that's how spread out something is. So you want everything to be the same. So A and B technically are both going to be things that result in a standard deviation of 0. If all of your observations are 0, then you get a standard deviation of 0. But if all of your observations are the same value, then you're going to get back a 0 as well. So you graph out what this looks like. And I'm just going to do a quick dot plot for both of these examples, just to show you what the shape of the distribution looks like. So if you have answer A, all observations are 0, then on your number line, you're just going to have all your dots are lined up at a 0, and it's not spread out at all, and so that's going to give you a standard deviation of 0. But for part B, if all of your observations are the same, you can still get a standard deviation of 0. So let's say all of our observations are 5, then you've got all of your dots are lined up here at 5. And so in this case, your standard deviation is 0. Here, your standard deviation would also be 0. If your values are all 2.8, and you've got all of your dots lined up here at 2.8, there's no variation, it's not spread out at all, so in this case your standard deviation is also going to be 0. So when you answer this one, technically if all of your observations are 0, your standard deviation is going to be 0, but you don't necessarily know that's going to be the case. If your data has a standard deviation of 0, it could be that all of them are 0, it could be that all of them are 5, it could be that all of them are 2.8, it could be a bunch of different things, but all of your data values have to be the same. So when you answer this one, you want to say all of the observations are the same value. Technically, if they're all 0, you get a standard deviation of 0, but you don't necessarily know that because that's just one case that you could possibly have. So on that one, just be sure you click all observations are the same value. For me, that was B. For you, it might be a different letter. But technically, A is kind of right, but it's not as correct as B. So that's the most correct answer. C isn't right at all. But they only give you one option on this one, so just be sure you get that one right. Going to be one that's similar. It says, over the past 5 years, 5 mutual funds had the same rate of return, so their average is the same for all of these people. And then they give you this standard deviations for all of them. The standard deviations are in percentages because the actual data values were percentages, and they just keep that same unit of measurement, bless you. And then they ask you which mutual fund was least consistent in their rate of return. So let's talk about what that means. Yeah, you only get a couple attempts with this one. They want the least consistent. So if you're not very consistent, then you're not really getting the same number every time. It's kind of jumbled all over the place. So if it's all over the place, then it's going to be pretty spread out. So if it's the least consistent, then it's going to be more spread out. And if it's more spread out and we're looking at standard deviations, do you want to try to find a standard deviation that's high or a standard deviation that's low? Right. So we're measuring how spread out something is. We want it to be very spread out for it to be not consistent. So we want to have the highest standard deviation. So if we look here, the largest standard deviation that we have is at 10.6. That's the largest number that we have. And so since that's our largest number, we'll go with Nomad. So this one, find the highest standard deviation, and then click the right one. So since they have the highest standard deviation, they're the ones that are more spread out. They're not as consistent. If you look at 6.6, this Vanity people, they have a pretty small standard deviation. So theirs isn't spread out at all. It's really clustered around whatever that mean happened to be. So since it's really clustered, it's going to be more consistent. So they're getting closer to that mean every single time, which is nice. It's probably the more safe one. And you're probably going to get pretty close to that average. This one, it's kind of hit and miss, so you're taking a risk with that one. You could get something that's a lot higher as your rate of return, but you could also get something that's a lot lower with your rate of return because it's just not consistent. So it's just depending on what type of risk you want to take, a safe one or a more risky one. Number 12.